Okay, statistics. Chapter 3, section 3.1 starts out with measures of central tendency. What it means by central tendency is things having to do with data in the middle, or the middle value of the data. The one you're probably the most familiar with, though you'll probably be familiar with a lot of these, is the mean. The arithmetic mean, which you guys usually refer to as the average. Of course, to calculate the average of something, you add all of the numbers together and you divide by the number there are. It doesn't matter if it's a population mean or a sample mean, they just have different variables. So if it's population mean, this is mu. It's not really how it's spelled, but phonetically that's how it's spelled. Mu is the population mean, so you add all the observations from the population and you divide by the number in the population. This x bar is the sample mean, so if you have a certain number of numbers in your sample, you add all those together and divide by however many are in your sample. Calculated the same way. So the following data represents the travel time in minutes to work for all 7 employees of a startup web development company. Compute the population mean. So I need to add all of those together. Divide by, looks like there are 7 of them. 100, 131. Looks like 174. So this should be about 24.86. So the average amount of time was 24.86. This doesn't mean that anyone actually takes exactly 24.86 minutes, but on average, that's how long they take. It says then take a simple random sample of 3 employees, complete the sample mean. We'll just do this one time. It says you can do it a few times. Let's say we've got a 23, an 18, and a 43. Now to compute this sample mean, we just add these 3 together and divide by 3. 41 plus 43 is 84. Over 3 is 28. So the average for those 3 people is 28 minutes. So that's really just how it works. It shouldn't be too bad, but there are some things we can do with this. For example, let's look at the next page. A professor has recorded exam grades for 10 students in their class, but one of them is no longer readable. I know nobody records things by hand anymore, but go with it. If the mean score on the exam was 82 and the mean of the 9 readable scores is 84, what is the value of the unreadable score? So remember how this formula works. So when I add score 1 plus score 2 plus all the scores to score 10, if I add all the scores together and divide by 10, I'm supposed to get 82. But if I add these other 9 scores together without the unreadable one, divide by 9, I'm getting 84. Now if I look at my relationship between these two, I'm going to multiply the 10 to the other side. That means all the scores together add up to 82 times 10, which is 820. Now all of the scores except the missing one add up to 84 times 9. That would be 720 plus 36, which is 756. What does that tell me? That tells me what's the only thing added here on the left that's not added on the right, that 10th score. So I should be able to subtract these two totals to see what it is. And that leaves the last score at a 64, which makes sense because the average comes down from 84 to 82 when it's in the picture, so it should be lower than the average. So that's something you can do using the average. Now, besides mean, there are more measures of central tendency that you've probably heard of. Median is the middle number in the set of numbers, but you must arrange them from least to greatest. If there's exactly one in the middle, it's the median. If there's not one that's exactly in the middle, you have to take the 2 that are in the middle and average them together. So again, from the travel time example, find the median. We already found the mean, so we're not going to do that again. So find the median. So I need to organize these from least to greatest. So 5, 18, 23, 23, 26, 36, 43. Now there's an odd number, and every time there's an odd number, there will be 1 in the middle. 1, 2, 3 on each side, and that leaves 23 as the median. And we already knew that the mean was 24.86, I believe, from before. Now, suppose the company hires a new employee. The travel time of the new employee is 70 minutes. I don't know why it's 1:30. 70 minutes. So we're going to put the same order. Now we're going to add that 70 minutes onto the end. Now that there's an even number, there's not 1 exactly in the middle. Both of these are in the middle, so you have to average them. So add them together and divide by 2 to get 24.5. So adding that 70 minutes brought the median up a little bit. So what did it do to our mean? We add them all together, and now we're dividing by 8. So the last one, it was on the first page, on the mean, it ended up being 174 over 6. So this should be 244 over 8, which is 30.5. So the median only came up a little bit, but the mean actually came up a lot. This has something to do with outliers. Median is pretty resistant to outliers. That's why we use it for things like median family income and not mean family income, so the billionaires can't skew the data. And we'll talk about that on the next page. Another way you can use median is, it says the median is 28.5. What is the missing value? Well, you know, if there's an even number, that the median is equal to 23 plus that missing value over 2. If we solve for the missing value, multiply by 2, means 57 equals 23, excuse me, plus the missing number, subtract 23, and you get the missing number is 34. So we can go backwards. It's not that bad. So what I was just talking about, a resistance statistic is a number or a summary, like the median or mean, said to be resistant if extreme values relative to the data do not affect it substantially. So let's think about things here. Let's say you have 2 numbers that you're averaging, 0 and 10. The average is 5. You add a third number in there, and it's a 300. Well, that 300 is an outlier. It's way different than the other numbers you've been seeing before, and it brings the average up to over 100. But for the median, the middle number between 0 and 10 is still 5, but you add this 300, well, now the middle number between 0, 10, and 300 is just 10, so the median didn't change a lot. So generally speaking, the stat between mean and median that is resistant is the median. So it would be better to use the median when you have a lot of outliers. Or really any outliers, but things like income in particular, we do. Value of houses. And so that's all for this video, and we'll continue in the next one.